A skyscraper in Shanghai generates electricity all day long. No panels on the roof, no panels bolted to the walls, just glass. Floor to ceiling, wall to wall, ordinary looking glass. And every square meter of it is quietly making power. Nobody standing on the street below has any idea. From the outside, it looks like every other glass tower in the skyline. No dark blue tint, no visible grid of cells, no hint that anything unusual is happening, and that's exactly the point. For 100 years, engineers have been fighting the same trade-off. You want a window, you get light, but zero energy. You want a solar panel, you get energy, but zero light. Glass or power? Pick one. That was the deal. Nobody thought you could have both from the same square foot of material. Today, that deal is dead, and the material that killed it is not some exotic future invention sitting in a lab 20 years away. It already exists. It's already being installed, and the physics behind it is stranger than almost anything else on this channel. If stories like this technology, quietly rewriting the rules while nobody notices, are your kind of thing, subscribe now, because there's a lot more coming. Let's get into it. The problem nobody wanted to say out loud. Here's the number that should bother you. There are more windows on the planet than there are solar panels. Every office tower, every apartment building, every greenhouse, every car glass, everywhere. And for a century, all of it did exactly one job. Let light through, nothing more. Meanwhile, the solar industry has spent decades doing the opposite. Traditional solar panels work by being as absorptive as possible. Black, opaque, hungry for every photon that hits them. That's literally why their black surfaces absorb almost the entire visible spectrum. Which is fantastic for a rooftop, it's useless for a window. Nobody wants to work behind a black pane of glass, or drive a car with a windshield you can't see through. So for 100 years, these two things, glass and solar power, lived in separate worlds. You could put solar panels on your roof. You could not put them on your windows. The two most abundant surfaces on every building on Earth, and only one of them was allowed to generate power. Architects tried compromises. Tinted solar glass. Thin film coatings that cut some light through in exchange for a trickle of electricity. But every version came with the same catch. The more power you squeezed out, the darker and murkier the glass became. At real efficiency levels, it stopped looking like a window and started looking like sunglasses. The question that sat unsolved for decades was brutally simple. Could you build a material that absorbs energy from sunlight and yet still looks completely transparent to the human eye? On paper, that sounds like a contradiction. Absorbing light and staying invisible are supposed to be opposites. The trick hiding in the light you can't see. Here's where it gets clever, and it starts with something most people never think about. Sunlight is not just the light you can see. Visible light, the rainbow of colours your eyes register, is only a slice of the full spectrum coming from the sun. On either side of it sit two bands you cannot see at all. Ultraviolet light, just past violet, and near-infrared light, just past red. Together, those invisible bands carry a huge share of the sun's total energy. Your eyes simply aren't built to notice it. That gap is the loophole. Engineers realised that if you could build a material that absorbs energy specifically from the ultraviolet and near-infrared bands, the parts of sunlight you can't see, and lets the visible band pass straight through, untouched, you would end up with something remarkable. A surface that looks perfectly clear to a human eye while quietly harvesting energy your eye was never able to detect in the first place. The material built to do exactly this is called a transparent luminescent solar concentrator. The name is a mouthful, so think of it more simply. It's a pane embedded with molecules tuned to catch invisible light and ignore visible light. Here's how it actually works, step by step. The glass, or in some versions, a thin plastic-like layer laminated onto glass, contains specially engineered organic molecules. When ultraviolet or near-infrared photons hit those molecules, they get absorbed and re-emitted as a different wavelength of infrared light, one that's now trapped. That re-emitted light doesn't just bounce around randomly, it gets guided, wave-guided, sideways through the pane like light travelling down a fibre optic cable toward the edges. And right there, along the thin border of the window, a border you'd never notice, sits a strip of narrow solar photovoltaic cells, completely out of your line of sight, catching that concentrated infrared light and turning it into electricity. Visible light never gets touched. It sails straight through the middle of the pane, exactly like ordinary glass. The energy harvesting happens entirely in bands of light your eyes can't register, and the electricity generation itself happens at the edges, tucked out of view. The result is a window that looks completely normal and generates power at the same time. This isn't a theory sitting in a physics paper. Researchers, notably teams working out of Michigan State University in the US, built and tested working versions of this over a decade ago, and the concept has been refined and commercialized since. And where it is scaled fastest, and where the manufacturing capacity now genuinely exists to install this at the size of entire buildings, is China home to the largest solar manufacturing base on the planet, and the country with every incentive to turn its glass and steel skylines into a second power grid. Why this is bigger than a neat trick? Now here's why this stops being a curiosity and becomes something close to a global energy story. Rooftop solar has an obvious ceiling. A building only has one roof. No matter how efficient your rooftop panels get, the amount of usable roof surface is fixed. And on a skyscraper, that roof is a tiny fraction of the building's total surface area. But walls are a different story entirely. A modern glass tower can be covered, floor after floor, almost entirely in windows. Multiply that surface area by every glass building in every city on Earth, and you're not talking about a niche product anymore. You're talking about turning the skin of civilization's built environment into a distributed power source. Every office tower becomes a small power plant. Every high-rise apartment block quietly contributes to the grid, instead of only drawing from it. And it doesn't stop at buildings. Picture greenhouses that generate power for their own climate control, while still letting in the exact wavelengths of light plants need to grow. Picture car windows and windshields trickle charging a vehicle's electronics while parked in a lot all day, invisible to the driver. Picture phone screens with a paper-thin transparent layer topping up a device's battery just by being out in daylight. None of these change how the object looks or works. That's the entire point. The energy harvesting is smuggled into a role the material was already playing. The catch nobody skips past. Here's the honest part. Because you deserve it. And because every real technology has a limit before it has a triumph. Transparent solar cells are, right now, less efficient at converting sunlight into electricity than a standard opaque black solar panel. That's simply the trade-off of letting most of the visible spectrum go untouched instead of harvesting it. A rooftop panel absorbing the entire spectrum will, watt for watt of surface, generate more power than a transparent pane, only harvesting the invisible edges of that spectrum. But that comparison misses the actual advantage. A rooftop panel replaces nothing, it's extra hardware bolted onto a surface that was doing nothing before. A transparent solar window doesn't compete with anything. It doesn't need its own dedicated space. It simply adds a second job to a surface that was already there, already installed, already paid for. The relevant question was never, which is more efficient per square meter? It's what do you get from surface area that would otherwise generate zero electricity at all? And the honest answer is, something is infinitely more than nothing. There are other real hurdles too. Durability over decades of sun exposure is still being tested and improved. Manufacturing at the scale needed to glass an entire skyscraper consistently, without visible defects, is a genuine industrial challenge, which is exactly why the countries with existing solar manufacturing infrastructure at scale have the real advantage here, and why China's position as the world's largest solar panel manufacturer translates directly into being the most likely place this scales first. And cost, at least for now, sits higher than a plain pane of glass, which means the earliest large-scale installations are showing up in commercial towers and pilot buildings before this technology works its way down to ordinary homes. None of that erases what the science has already proven. It just marks the distance between what works in a demonstration and what gets installed on every building on your street. And every year, that distance gets smaller. The bigger shift underneath all of this. Step back and look at what's actually happening here, because it's bigger than one clever pane of glass. For the entire history of solar power, we treated energy generation as something that needed its own dedicated space. A field of panels, a rooftop array, a patch of land set aside specifically for the job of catching sunlight. Energy generation was always separate from everything else a structure was built to do. Transparent solar breaks that assumption completely. It doesn't ask for new space. It doesn't ask a building to look different, or a window to stop being a window. It asks an existing surface to quietly do one more job in the background, using a slice of light your eyes were never built to see in the first place. That's the same instinct running through the smartest infrastructure decisions happening right now. Not building bigger, separate solutions. Finding the invisible slack already sitting inside things you use every day and putting it to work. A window that was only ever a window until someone realized the light passing through it was carrying more than warmth and brightness. It was carrying power nobody was bothering to collect. So next time you're standing in an office or sitting by a window at home, take a second look at the glass in front of you. It might just be glass. Or it might already be a tiny power plant, running silently 24 hours a day, and you would have absolutely no way of knowing just by looking at it. Which raises the obvious question, and I want to hear your answer in the comments. If every window on Earth could generate electricity for free, what's the first building you'd want to see it installed on? If this changed the way you'll look at the next window you walk past, that's exactly what this channel is for. Hit subscribe, turn on the bell, and I'll see you in the next one.